Okay. Okay. So we can start now. In previous week, I already introduced to you one method for doing the rest hole, on the grayscale image, right? In some situation, we can do rest hole on the a color image, It's especially on the something called the HSV color image. So what is it? So normally, right, we have the color image in the RGB space. We can call this RGB space. So normally for doing the image processing in the color image, they often change from the RGB space to the HSG space. Why? Why? So I will do some example for you here. Okay, yeah. Okay, this is the pen software, right? The pen software, and to do the rest hole on the RGB image, right? You have to change the R value, G value, and B value according to your requirement. But let's imagine if some line is project on the object, so the color of the object will change. So when we change from the RGB space to the SSG space, it will help you to choose the rest hole image easier. Why? Now you can see here. Example here, I have the pen software, and I use the color image here. And example, I choose the blue color, And here you can see that this is the panel of red, green, and blue. And here this is the H, S, and L. So S and L are S and V. It is similar, just different mathematics. So they know different. So let me do some example. We have a line project on object, blue object, and the color object will change, something like this. Okay, so during it change the color, it change the intensity, right? So what happened with the RGB image? What happened? All the red, green, and blue value change, right? All the value change. But in the SSL, what value change? Just one value change. So it's here you can see that if you change the RGB space to the XSL or HSV space, it will have you to choose the rest hole image easier. Okay. So this is the reason why they often change from RGB image to HSV image. So what is the HSV image here? So the HSV image is composed the name something Hui. So this is the I say the picture of the HSV here. So the H will be the color, and the V, right? V and S will be the intensity. So H, V, and S will change from 0 to 1. But here they change from 0 to 360 degrees. So that means according to a degree here, you will have exactly the color So example here, where change from 0 to 360, you will have the color space here, the color space here, the color space here. Okay. Okay, so that means if the Hue value, is resemble 120 degree, so that is the green color, green color. Okay, 0 red color. Okay, so that means the Hue value will choose the color, and uh, and the S value here will decide the, how to say, the blur or the intensity of the image. Okay, so S equal to 1, you will have a very bold, right? Very bold color, right? And then change the color here, right? It will be very light, something like that. Okay. Okay. So to change from the RGB space to the HSV space, we have some formula, and this one is the most important formula here. So this is the formula to change from RGB to HSV. So let me explain to you. Example, you have an RGB image here, and to find the V value, just find the maximum of this value. So when you find the maximum, you have the V here. And then you find the S value. So the S value will be this formula. V minus min RGB divide V. Right? Okay. Okay. So what happened with this one? Okay, wait a moment, please. Okay, let me explain again. Okay, if you have an RGB image, right, and then you find the maximum, and then you have the V value, and to find the S value, you can find this, use this equation. You find the mean, and then you use this equation if the V different 0. Okay, and then next you find the S value, according to the V value here. If V, the maximum is red value, you choose this equation, and then if green, you choose this equation, and then this is, you choose this equation. Okay, and then if the S value, if the calculation smaller than 0, so you have to add 360 degree, and V and S value always from 0 to 1 here, 0 to 1 here. Okay, so this is the formula. So okay, so next I will do some example for you to do for clearer. Okay, so please wait a moment, please. Okay, let's do some example. Why? Okay, here. Example, I give you the RGB value is this number. RGB value is this number. So what is the value in HSV? Okay, let's do the example. We have RGB is this one, right? So Here, here you can do the normalize. It's okay. You don't need to do this one. It's okay because just the divide 255 it does not change the formula. Okay, so the RGB will be this one. Okay, so the first thing we find the max value, right? To find the V, right? Find the V here, right? So we find the max value. So the max value, which one? 300, sorry, 200 divided by 255, right? So the V value is this one, 0.78. Okay. Okay. And then the next value, X value, right? S value, right? So what is the formula? This one, right? Because V different 0, right? So we use this function. Okay. So we find the mean here, right? So that means this equation is max minus mean divided by mean, right? Divided by max, right? Max minus mean divide max, right? So we have this one, max divided by mean, sorry, max minus mean and divide max. So we have this number. So V and S, right? So the next one we calculate is H value, right? H value. So what is H value here? Because the previous one we choose the maximum is G, right? Maximum RGB is G value, right? So we choose this equation, right? We choose this equation. Okay, we choose this equation. Okay, so example here, because this number is too big, so I divide 60. So this one become 2 plus B minus R, right? Divide max minus mean, right? Is it? Yeah. Okay. So this is equation. Okay. And after this one, we have this number, right? This number. And then we have to multiply 60 again, right? To go back to the original value. So the H value here is 156.9 degree. Okay, so this is the procedure to find the S and V value. So do you have any questions on this one?
Ủa thầy V math là bắt buộc phải chia 250 hả?
Because as I said before, the V must be from 0 to 1, right? Must be from 0 to 1. So we have to divide 255. Okay.
Ủa thầy, với lại giá trị red với green giả dụ bằng nhau thì mình chọn cái công thức nào hả thầy?
Okay, this is also the same question in the same question. Okay, here. Okay. Example in this one, right? Max a red and green value, right? It have the same value, right? The same value, right? So this one we can calculate, right? Okay, right? And S we can calculate, right? And how about this one? Red and green. So that means red, right? And green value, red and green. So example, I replay this one in red, right? I replay this one red. So that means this formula, right? This formula and this formula, and this formula are similar, right? But different side, right? different size. Is it? Yeah, different size. So red and green, right? So you can choose any uh, equation here. Each will give you the same value. It will give you the same value. Yeah. So, okay. So okay. So this is the situation. Red and green value have the same value. Have the same value. Okay. So we have many and many how to say situation here, right? So I think that you can go home at home. You can try. You can try and understanding by yourself first, and then maybe next week we will have a discussion about this. Okay. Yeah. So the next one is this one, right? So any more questions here? Any more? No, right? Okay. So I will do the programming for you, the example programming for you. Here, this is the RGB value here, right? RGB value, right? So we do the programming here. The RGB is this form, right? But as I said before, right, when you use the OpenCV, right, the OpenCV will store the color image in the format BGR, right? BGR. So that means B will be 130 here, right? 130. And then 18 will be the last one, right? BGR, okay? BGR. And then uh, we have some one formula we call this is one function called this is CVT color here. CVT color. So you use this function to change from RGB to HSV space, and then you have the result here. Here, the result. The result. Is there any different from the the calculation? Is there any different? Is there any different? HE 156, right? Okay, similar, right? S is 0.91, right? Okay, and V is 200, right? 200, because we want to change it to the 0 and 1 range, right? So we divide 2 by 5, right? So this is 0.78, right? Right. But in the OpenCV they didn't, right? They don't do the dividend, right? But in the calculation you should or you have to divide it. Okay. So this is the example how to transform RGB to HSV. Okay. And the next one is okay. And another example is if I have the HSV space, how can I change back, convert back to the RGB space? How can I convert back to it? Okay, this is the example. This is the example, right? This is the example. Here is the example here. Example, you have the value V is 0.9, sorry, 0.5, S is 0 degree, S equal to 1. So what is the value in RGB? What is the value? So let's have the example. Okay, here. So this is the procedure for you to convert back to the RGB. So just follow this procedure. You can do all the example. First, we use the equation 7. because we have the V value here is 0.5, right? 0.5, 0.5. So that means we can find the max value here, right? So the max value here is this number. The max value here is this number, right? Okay. And then from the formula A. So S here equal to 1 here, right? So here become 1 here, right? So that means max minus min divided by max equal to 1. So that means min equal to 0, right? Min equal to 0. Okay, min equal to 0. So when min becomes 0, so that means it's 0. This one is 0. This one is 0. Okay, one is 0. Okay. So another A, we have the H become 0, right? Become 0. Become 0. So if H here becomes 0, so that means H1 become 0, right? So this one will be 0, this one will be 0, this one will be 0, right? Okay, please wait a moment, please. Okay, so we continue. Okay, so let me explain again. So this one is we have this formula. So we have the max value here, right? So from the equation A, we can find the mean value equal to 0. So this is 0, this is 0, and this is 0. Okay. So the h here equal to 0. S here equal to 0, right? So here we have 0 here, right? So S1 will also 0. So this is 0, 0, and 0, 0. So from equation 3, 4, 5. So which equation can make the H1 become 0? Which one? Which one? Just equation 3 can make it. This one must be, the minimum will be 2. The minimum will be 4 here, right? 4 and minimum is 2, right? So just this one can make the equation become 0. So we choose the equation 3. Equation 3. So because this is 0 here, right? So that means from this equation, G must equal to P, right? Right? G equal to B, right? Okay, G equal to B. And here we have G equal to B here, right? And the mean value here is 0, right? Here, we have the mean is 0 here. We have the mean 0 here. So That means G equal to 0 or B equal to 0, right? Right. But we have G equal to B. So that means G equal to B will equal to 0. Okay. So that's the example. So do you have any questions? Okay, let's do another example. Okay. Do another example. Okay, another example here. B. Example, I give you this one. So how to calculate from HSG to RGB again? Okay. Similar. And we have what value? This one, right? This one. So from this one, what is the max value? We have the V is 0.2, right? 0.2. So the max will be 51. The max will be 51, right? The max will be 51. And then from the equation A, right? We have this equation. Right? So max minus mean equal divide max equal to 0.8, right? So that means we have the mean value will become 10.2, right? 10.2. Because we have already have the max value here, right? So we already have the max and the mean, right? The mean. Okay. So here, right? We have the max, have the mean, right? Max and mean. Okay. So we have H here is 120. Here 120, right? So that means X1 is equal to 2, right? Equal to 2. So 2, and 2 here, right? 2 and 2 here, right? And max minus mean, we have the max, we have the mean, have the max, have the mean, right? So in this three equation, which value can make the X1 become 2? Will become 2? This one cannot, right? Because the minimum is 4, right? Minimum is 4, right? And this one is also cannot, because when divide it will be different too. So just this equation, right? Just this equation. So if this one we choose this equation, so B minus R become 0 again, right? Become 0 again because 2 minus 2 is 0, right? So now we have B equal to R, right? B equal to R. And here in this one, right? In this one, we already have the mean value. We already have the mean values. So that means B equal to R. So B equal to R here. B equal to R here, right? So here we have the B equal to R, and because we have the mean values here is 10.2. 10.2, right? R will be bigger than R, G and B, right? R will be bigger than G and B. So the mean value is 10.2. So G may be 10.2, right? Or B will maybe 10.2, right? Right. But we have the B equal to R, right? Sorry, B here is R. Okay. B equal to R, right? B equal to R. So if B equal to R, So that means B equal R and have the 10.2 again here, right? 10.2 again. Yeah. Okay. So this is another example. And we also have another example. Maybe when you go home, you can do it by yourself here. Okay. Okay. So, and this is the explanation of the function CVT color. So this one, CVT color. Okay. And the application here is example. I want to find the color of the purple color here. You see, I make the mistake. This is purple, not blue. Purple color here. So I change to RGB. I define the HSV low and high, low and high, low and high, low and high, and then I use the slider. I use a slider. And then after I slide it, I use the function we call it the in range here to threshold the image in HSV. Okay, this is the in range function. So another function we call the in range function. So after this step, you will have this maybe this one, this picture. You have this picture. You still doesn't have this picture. This picture you will have in the future. Now up to this step, you have this picture. Okay, and you can see that in this picture, right? You have a noise, right? Some noise. This is also the noise, right? This is the color. This is the color of the bubble. Where is it? Here, the color here. So maybe next 3 weeks, I will explain to you how to obtain a very beautiful image on the left hand side here, right? We have to apply some algorithm to have the beautiful image on the left hand side. Okay. So this is the code, and then I think that you can have the reference. Okay. Okay. And example, I want to recognize not only purple. I also recognize the red color. So I will choose tools, right? Two group, right? Two group of HSV for each color. So and then I mark it, right? Mark it here, and then you have the result. And you have the result here, right? And then you have the result. Here you see the red image. This is the red image, right? And this is the purple, and this is also the purple. Okay. So this is the one application of the RGB image and HSV image. And this is another example. Maybe you already did in the exercise. And after you do the rest hole, and then you can have the very nice hand here. Okay. Okay. And another example is I apply on the RGB image, not HSV, directly on RGB. Why? Because this is the static image, not dynamic image, not in the video. So the intensity will not change. So doing on the RGB image is possible. So I also choose the lower and upper, lower and upper, lower and upper. So this is the result. From the here I recognize the blue color, and then I saw the image, and then I have this person, and then I add the person into another background, something like this here, and then you have the new image. Okay. Okay. So this is what is on the rest hole image, rest hole knowledge, right? threshold. What information you have to remember on the threshold image? Okay, and this week we will go on the next one. We go to on the next one. Because this is a spatial operator. Spatial operator. So what is it? What is it? Someone already did the exercise, something called adaptive threshold, right? Adaptive threshold. So this algorithm is a kind of spatial operator. So what is it? So in the spatial operator, in the previous lesson, you just do the operation on the pixel, on a single pixel image, on a single pixel image. On this spatial operator, you will do the operation on the matrix of pixel, matrix of pixel. So this one is the matrix of pixel is symbol 3 by 3. And one here you have one thing we call this is the kernel, or one thing we call the mask, mặt nạ, mask. Okay. In this one is also the number, and one thing we call this is the anchor point. The anchor point is the point that when you apply the kernel on the image, it will give the result. Example here, the anchor point in the between. So when you apply the kernel on the image, the result will give you on the middle here, in the middle here. Okay. So in the spatial operator, we have two very important operator. We call this the cross correlation and convolution. Cross correlation is for symbol image recognition. Later I will explain to you. Tương quan ha. Convolution is for filter image filter. Convolution, this is tích chọc. Okay, so how can it do? So let's have their mathematic. So this first is cross correlation. The cross correlation, this is the name like tương quan. So this is the name, and then from the name you can imagine that's what is this function, right? That's the find the how to say the similarity between two matrix, right? Similarity, right? So they will apply this equation to find it. And the symbol of the cross correlation is this one, like the lamp in the electric symbol, right? Okay, this is the symbol of cross correlation. Example here. You can see here when you have the kernel, this one the filter on the kernel, right? When you apply here, and then you have the result here, the anchor point is here, right? This is the anchor point. Okay, so how can they do it? So let's go up. This is the equation, how to do it. This is the kernel, and this is the image window. This is the window. So when we apply the kernel on the image, so this is the equation. Here, the very simple equation, what? F1 multiply H1, right? And plus F2 multiply H2, right? F3 multiply H3, right? And then this is the final, right? This is the final. Okay, so let's see this example. Is it minus 3? The result is it minus 3? Here. 3 multiply minus 1, right? Here. Okay, here. 0 multiply 0, right? And here 1 multiply 1, right? So is it this equation? This equation, right? This equation, right? So the result here is minus 3, minus 3. Okay. Do you have any questions? Anything unclear? Okay, so let's go to the next one. Okay. In this one, we have a small problem. So the result just inside this rectangular, right? How about the value outside here? How about the value outside here? So this is why we have to do something called a batting, right? In the previous exercise, right? You do the batting. Okay. So normally to solve the problem of the border like this, right? The border like this, and we have four solution. First and the second. So the first and the second, we rarely use it, so we ignore it. Okay, delete it. Okay, just two remaining solutions. We often use it. And this one is more often. It's more often. Okay, this one is also use it. Okay, so what did they do? Uh, this technique, right, or this solution, you already know, right? Just add 0, one more 0 and one more column, right? And another is duplicate pixel. Here you can see in the animation they duplicate the pixel at the border, you can see, and do the correlation. Okay, so this is the duplicate pixel. Okay, so this is the correlation. So do you have any questions? Anything unclear on this algorithm? Okay, so next one. This is the correlation, right? So the next one is, we call this is the convolution. Someone maybe already have knowledge or heard about something called a machine learning or artificial intelligence, right? We call this is the convolution neural network or something like that, right? So this is the mathematics of the convolution. So what is it? What did they do? First, this is the symbol of convolution. Like the star, right? Like star. And this is the mathematics. So this is a very, how to say, difficult one, right? But I will explain to you easier here. This is the mathematics. So what is the convolution? Briefly speaking, that convolution is the correlation. This is the correlation, but before doing the correlation, we have to flip the kernel. So be careful when in the exercise, if it asks you to do the convolution, the first thing is you have to flip the kernel. Okay, you have to flip the kernel. So what did they do? So example, we have the kernel here, right? We have the kernel. So we have the flip, and then flip around the x-axis. So x7 will become x1, right? So here, x1, this one, right? And this one become this one, right? and then flip around y coordinate, right? Y coordinate, right? So this one will become this one, right? And this one will become this one, right? So this one here, and then do the correlation. So here, do the correlation. Okay. Okay. And this is the example. As I said before, we often use the convolution in the something like the filter. The kernel is the filter kernel. Kernel here is the filter kernel. Okay. As I said before, the anchor point, right? When we apply this kernel on this image, right? On this image, the result will give you on the at the anchor point, right? At the anchor point. So be careful at the anchor point where we define the anchor point. Okay. So example, this one is the example of correlation, right? It is similar to previous example, so I think you can have a look at this, and then maybe you can study it by yourself at home. Okay. Okay. So this is the example of convolution. The convolution. This is also another example. And one thing I want to mention here, if the kernel is symmetric, symmetric tiếng Việt là gì nhỉ? Gì ta?
Đối xứng này.
Đối xứng. Ok, đối xứng, symmetric. Okay, if the kernel is symmetric, you don't need to flip the kernel, because if you flip the kernel, the result is the same of with the original one. So don't need to flip the kernel if it is symmetric. Okay. Here example, this is symmetric. Okay. And if you apply this one on this one, you also have the result here. Okay, and then you have another. Okay. This is the programming. Don't use the OpenCV functions. Okay. Okay. Let me do the example for you, programming for you. Okay. Example, we have this one. Oh, not this one. Okay, not this one. Okay, this one. Okay, let's see. Okay, example here. Okay. Okay. If I give you this one, right? This is the image, right? And this is the kernel. And do the convolution by hand. So what will we do? So first, padding. Okay, padding, and then flip the kernel. Right? When you flip the kernel, you will have this kernel. Okay. And then apply this kernel on this image, right? Apply this kernel to this image. And this is the example. This is the example of the calculations here. You can see, right? 9 multiply 0, 8 multiply 0, 7 multiply 0, right? Okay. That means apply this one on this one. Okay. and you have this number. Okay, and this is the result of doing by hand. This one, okay, doing by hand. And then we do the programming by using the OpenCV library. And in the OpenCV library, you have one function called the filter 2D here. Filter 2D here. So this one is do the correlation. The correlation. As I said again, this function do the correlation, not convolution. So that means in the programming, if you want to do the convolution, you have to flip the kernel first and then give the kernel on to this function, right? So please remember. So this one, the image input, image output, the depth, and then the kernel. So how can we define the kernel here? So this one I show you here how to define the kernel. This is the flip bit kernel, right? Flip bit kernel. And then you define it at the kernel here. So this one will become this one. So you can study how to define the kernel here. Okay. And the point and the answer point. The answer point here is minus 1. Minus 1. That means in the middle. In the middle. Okay. So 0 and 0. Okay. It's the default. So just let it 0 and 0. Okay. And here you can see that you have the result here. You have the result here. You can see that this one and doing by hand it is identical. I said it is identical, right? Identical. So if you do the calculation by hand different with your programming, maybe you are doing wrong. Okay. So please remember. Okay. And the format or the function is here. Okay. It's here. This one. Yes. Okay. So this is the demo of the programming and doing by hand. Okay. The next one. Okay. So as I said before, cross correlation and convolution, they have their purpose, right? So the first, the convolution is for the the filter. So one application of convolution, we call this the average filter, or blur image or blur filter. Similar name. Blur image or average filter. Why we call this average? Because we apply the kernel, this one. Apply the kernel. So this kind similar to what did you do? What will you do? Example, you have a 3 by 3 here, right? So if you apply this kernel on here, it's similar to do the average of this matrix, right? Divide by 9, right? Multiply, because this is multiplied by 1, right? So this kind of like doing the average, right? Average. Here it is 5 by 5 multiply 5, right? And the blur color and the blur filter is applied for the filter the image on similar on the picture here. Example, we have the Mona Lisa picture here, right? And if we zoom it, we have some something called it a pepper noise. And if you apply the blur image, you will have the better result on here. But the image will also will blur a little. Okay. And this is the movie. the movie explain more about the blur image. So if they apply the blur kernel here, you can do it. You can see here. Okay, on the next slide. So this one become 10, right? Okay, here this is the application of the blur image. Here you can see it because we have the zero value here, right? It's like it make the image will like some have a hole here, and this one is has some kind is a noise, right? So by doing the blur image, you can reduce this one. Reduce that means increase the number here and decrease the number here. Here you can see here. So this is the result when you apply the average 3 by 3. Yeah, yeah. Okay. Okay. So normally the blur image in the image processing before doing the recognitions, you have to apply the filter on the image first, and one filter is more often used is the blur image. Okay, here example here, if you apply the blur image on this image, you can have the something like the edge detection, okay, or the corner detection here. Okay. I will explain to you more on the maybe next 3 weeks or 4 weeks. Okay. Okay. And this one is another, also we use the average. And here you can see that the pepper noise is reduced, but the intensity or the image quality is reduced also. Okay. And this one is also the function. Okay, I already explained to you. Okay. Okay, this one also. See also convolutions. Okay. Okay, the next one. The next one is the median filter. Median filter. So what is the median mean? What is the median mean? So we can have a look at this example. What is the median value mean? Here example, you have the window 3 by 3 like this. 3 by 3 like this. Okay, so the first is you have to list all the values List all the values, right? List all the value, and then choose the value between. Okay. Obviously the value 27 is the value between this value, between two sides, right? Between two sides, right? Okay. Okay. So by apply the median filter, that means you replay the value at the answer point. Example 19 here, replay by 27 by the median value, by the median value. So this one we call, this is the median filter. This is the median filter. This is the median filter. Okay. This is the median filter. Okay. So this is example. This is the image with the background noise. And if you apply the median filter, you can have this image. Okay. So what is the difference between median filter and blur filter? It have the same function, reduce the noise. But here you can see that if you apply the median filter, the image quality reduce not too much. It's also reduced, but it's reduced not too much. Okay, so it's different from the blur filter or average filter. Okay, so this is the example. I give you this one. So apply the median filter by hand and give the result. If the kernel is 5 and 5, and then use the and then you use the median filter function, OpenCV function, to apply on this image. Okay, to apply on this image. And let's have a look at the calculations here. Because we use the kernel 5x5, so we betting one more. So we betting two. Because we use 5x5. 5 multiply 5. Okay. So we list 5x5 here, right? So we list all the value in the 5x5 format, right? In this way. We 5x5 value, right? 5x5 value, right? So here you can see that the number zero is in the middle. So this is the median value. And then you can move to the next column, right? Move to the next column, and then the next column here, right? And then after you serve all the image, here, you have the result here. Okay, you have the result here. And then you can apply the function. We call it the median filter function here. Here we have the function called the median blur. And then after you do the median blur function here the window size is 5x5, right? 5x5 here. Window size here. Okay, the size here, 5x5. So this is the result here. Oh, this is the result. Here. This is the result. Okay, from the result you can see that it's identical to your handy calculation. Okay, it's will identical. So it must be similar. Okay, so this is the median filter. This one is also the median filter. Okay, apply on the image. Here you can see that the pepper noise is eliminated, right? And the quality of image also reduced, but not too much. It's okay for the recognition. Okay, I think that's enough for you today. Next week we will study some more very important filter like the Gaussian filter. Right, it's a very very important filter. I can say that um, maybe many weeks remaining. We have some algorithm. So before applying the algorithm, we have to apply the Gaussian filter. It's the pre-processing of the algorithm. So this is very important. So next week we will study about it. So okay. So up to this step, do you have any questions? Up to this step, do you have any questions? Okay. Okay.
Thầy em hỏi tại sao giờ mình có cái median filter để làm gì thầy? Tại vì mình có một cái là cái filter cao với một cái filter thấp rồi, cho cái median filter để làm gì nữa thầy?
I really don't understand what your question.
Dạ. Ý em là mình cái filter thì mình có một cái là để em xem lại cái slide.
Okay, so I can guess your questions. Why we have median filter and why we have the something kind blur filter, right? Why we need it, right? If
Dạ,
we
dạ,
have blur filter, why we need median filter, right? Okay, some filter, as I said before, first thing filter is the function, right? Filter is function. We don't have any fixed how to say fixed procedure. That's okay. On this image, we have to apply the median filter, or on this image, we apply the blur filter. It's the function, just the function. You have to apply it based on different situation. Example, blur image. As I said before, it can help you to make the image more clearer for better recognition on the edge detection, something like that. They will have the function, right? They will have the function. Median filter is also another function. Here you can see that you can reduce the noise. You can reduce the noise, and it also can reduce not too much the image quality, right? If comparing with the blur filter. So it's just a function, right? You have to choose or apply it based on different situation. They don't have the fixed procedure for you. Okay. It's like a weapon, right? If you have many weapons, you will have how to say you some kind you will have I don't know how to say, right? You will have like the worker ray 1 and worker ray 7. They are different. They are just different because of the weapon. If the worker in ray 1, they don't have example 1 or 2 weapon for doing something, right? But the worker ray 7, they will have more weapon, and then they do faster, or they do is more quality, something like that. Okay. Later, we will have another filter like the Gaussian filter, and this is a very, how to say, it also have another function. Okay. So do you have any more questions? Okay, if you don't have any more questions, I think we can dismiss the class now. Okay, thank you.